Alright, so here's the rest of the study guide, starting with number 6, graphing a rational here. So the first thing I notice is the powers are the same, x squared, when you go power term over power term, they're equal. So when I divide, I get y equals 1. Next, I look at, see if we can factor. So it's -4 and +1. Let's take out an x plus 3. There's nothing removable, so there's no whole. There's also no slanted asymptote because there's a horizontal. We have two vertical at 0 and -3, and they both are odd. So there's my domain. We have x-intercepts at 4 and -1. Again, they are odd. They're going to cross. The y-intercept, when you plug in, there's no y-intercept because it's undefined. We have an asymptote over the y-axis instead, and then we're going to graph it. So let's start with 4 and -1. The y, there's no y-intercept. Let's put down the asymptote, so it's 0 and -3, and we have a horizontal one at 1. Sorry, put out the right one there. Now, it's a good reminder to know that the horizontal tells us the end behavior. So I have a point here on the right, so the end behavior to the right is going to be the horizontal, and then it's going to curve and go down to -infinity. Now I know, because it's an odd vertical asymptote, the other side is up. I have a point. I'm not worried about crossing over the horizontal because it's not about that. So it can cross the horizontal. The horizontal gives me the end behavior. Sometimes it touches, sometimes it doesn't. I still need a point here on the left. So we have one at -3, so let's see what -4 gives me. So if I'm going to plug in -4, I get -8, I get -3, I get -4, and I get -1. So I know the answer is positive because it's above. So again, odd vertical asymptotes. So yeah, all these negatives will make it positive. So it's 24 divided by 4, 6. So at -4, I can go to 6. Now I have a point to curve through to make sure the end behavior, and at the vertical asymptotes it's either infinity or -infinity. So two vertical asymptotes creates 3 pictures, left, middle, and right. If I had one vertical asymptote, it'd have 2 curves. Okay, number 8. Oh, increasing and decreasing. Sorry, let's go back. So this first is increasing. In fact, everything's increasing. So everything's increasing, and we know x can't be 4 or -1. There's nothing that's decreasing. So it's going up, going up, going up, to left to right. Number 8. So step 1 is we're going to factor. So the numerator, I'm going to factor out a 3, and I'm going to be left with x squared subtract 9. In the denominator, I'm going to factor out the first 2 terms. I'm going to do it by grouping. And then the next 2. Keep factoring. So we got x plus 3, x subtract 3. Here at the bottom, you have x squared subtract 9. And again, that's x plus 3, x minus 3. And still have the x subtract 6. So this function has 2 holes. So first of all, the domain restriction. So x cannot equal positive and -3 and 6. That's from the bottom. Positive and -3 create holes. So I'll put that down. And 6 creates a vertical asymptote. The bottom is more powerful, so it's y equals 0. There's no slanted asymptote. The x-intercepts. Well, remove what's left, and what I'm left with is 3 over x subtract 6 once you remove everything. So the numerator only has a constant. There's no variable. With no variable, there's no 0. The y-intercept, if I plug in 0 for x, I do have something. 3 over negative 6, which is negative a half. And now I can graph it. So at least I have negative a half. I have a couple holes that I haven't found. Let me do that. So if I plug in 3 take away 6 is negative 3. So altogether that's negative 1. If I plug in negative 3, I get negative 3 take away 6. So it's like negative 3/9 or negative a third. So I can put those on my graph too. So I got one at 6. I have another one at 0. 3 and negative 1. And then negative 3 and a third up here. So I already got a sense here, hop over the holes, what this curve is going to do. So the left end behavior on the right. Be careful of the negative a half and negative a third. Negative a third is a little higher. Just make sure it has a nice curve to it. Here, what's a nice number I could plug in? So what would happen if I plugged in, what's that, 7? So what would happen if I plugged in 7? So 7 take away 6 is 1. So 3 divided by 1 is 3. So 7, it's 3. So now I got a point. So I know where it's curving towards. So at the vertical asymptote, it goes to infinity. And then it follows the horizontal for the end behavior. Going down, going down. So everything is decreasing. And then obviously where it's undefined, it's neither increasing or decreasing. But the rest of the graph is all decreasing. Nothing is increasing left to right. Number 10. This question has to do with what do we know about the power term? So both ends are down. So that means it has to be negative, and that also has to be even exponent if both ends are down. One end's up, one end's down. So because the right end is up, it is positive. And because they're going in opposite directions, it's a positive power term with an odd exponent. Synthetic division, I know you guys can do this. So 2, negative 8, negative 22, negative 15, and 20. And then we write the answer as 2x cubed plus 4x squared plus 2x, subtract 3, and then the remainder gets written as a fraction over the divisor. Again, dividing with synthetic. So 1 degree less, so it's going to be 5x to the 4th. Oh no. What am I missing? I need a 0 in here. So this one is here. So it still worked out. Just so you know, on the answer key it says negative 3, but it doesn't mean it. Negative 2 and positive 5 definitely is positive 3. So now we can write down our answer. 5x to the 4th, 0x cubed, so 1x squared, 1x of 5, and then the remainder is positive 3 over x minus 1. So again, the answer key, just a little typo in terms of what the answer is. 14. We have to do long division here, so let's do that. That's because it's not a simple linear. Make sure I don't miss any missing powers. They all seem to be there. So 20 divided by 5 is 4x squared. And then negative 4x squared. So there's no remainder. So I'm going to bring down what's left, which is 10x plus 1. So 10x divided by 5x is 2. And then the remainder is 3. So we're going to write our answer as 4x squared plus 2. And then the remainder as a fraction over the divisor. Make sure that when you subtract a negative, you're really adding, so that's why it's 3. All right, use the remainder theorem. So the remainder theorem allows us to do synthetic substitution. So we're going to take the 3. No missing powers, that's good. I think on the answer key it's not 3, but they put a 5 in there. So it's just a different question. So using what's you're given on your packet, that's the answer. So that means when you plug in 3, the answer is 0. So you're evaluating that way. So on the answer key it said use 5, so I don't know why the number changed on the answer key. All right, number 18. The answer key is not mine. It comes from another source, place entirely. So I'm just using someone else's material here. But anyways, plug in 1. Using synthetic substitution, this is what you would do. This one does seem to match. So that means f at 1 is equal to -4. And then number 19, same idea, -3. Be careful of missing powers, so no x squared. So I got it that time. And then do the dividing, so the remainder. So that's what I'm looking for, just the remainder at the end. So f at -3 then equals 22. So it's a different way to evaluate. This would be a good example where plugging in -3 would be a lot bigger numbers and a lot longer to do. Then the synthetic division is a lot easier, and you're just looking for the remainder that gives you the same answer. That's the remainder theorem. Next is the factor theorem. So how do we know if these are factors? If the remainder is 0. So be careful of missing powers. We don't have that. So each one, I'm just going to make sure. So the first one gives you a remainder of 0. So that's a good one. Yay. The next one, make sure you use the 0. So it's +4. Again, it works. Beautiful. If it doesn't give you a remainder of 0, it doesn't work. So -3. So this one does not. So this one. So these are the two that are the factors. Again, how do I know if it's a factor? So start with the 0. We're seeing if the remainder is 0. So this one doesn't work. -4. That one works. And then the last one, 6. This is going to go way out of control. So I can tell that that remainder is not. So as soon as I realize that the numbers are getting huge and there's no way the answer is going to be 0, I just stop. I don't need to keep going. 23. So the rational zero theorem, so the leading power coefficient is 1. So just look at the last number, all the numbers that go into 15 evenly. Number 25, the last number, so all the numbers that go into 28. And then we have a fraction. So 2 means that the two numbers that go into 2 are 1 and 2. So dividing by 1, it stays the same, but dividing by 2. So 1 divided by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So I need the 7. 14, 28. all of those when you divide by 2 are already on my list, and that's it. So I told you to skip 26 to 29. Number 30. Find all the zeros. So that could be factoring, rational zero theorem, what you need to do. First thing I look at is, can I factor? It looks like a simple trinomial. So what two numbers multiply to 72, negative 72, and combine to 14? So there is actually two numbers that fit. And the two numbers are positive 18 and negative 4. Then you take each one equal to 0 and solve it. So in this case, when you subtract, you're going to get an imaginary answer. So when I take the square root, I know the answer is positive or negative. I know it's imaginary because taking the square root of a negative number is imaginary. And then the square root of 18. So think of that. The square root of 18 is 9 times 2. Think of it that way. So the square root of 9 is 3, and what's left over is 2. The other one, I'm going to add 4. This one's real. Take the square root and rational. So these give you all the zeros. If I'm going to write it as factors, as linear factors, you go x subtract 3i root 2, x plus 3i root 2, and then of course x plus 2, x minus 2. So you have your zeros in the factoring. 32. First I look for is it factorable? It is not. So when I look at it by grouping 1 and negative 3 and negative 13 and 15, it's not going to work out, so I need a list. So 1 and 3 and 5 and 15. So it's a short list. So 1, negative 3, negative 13, and 15. So the good news here is this does add up to 0. So when you add it up, it adds up to 0, so positive 1 works. And then once it's here, then you can just write it from there. So this is 1x squared minus 2x subtract 15. Then we're going to solve that. So again, we can factor this. That's negative 5 and positive 3. And then when I solve it, you add 5 and subtract 3. So in factored form, positive 1 gives you x subtract 1. Positive 5 gives you x subtract 5, and negative 3 gives you x plus 3. And then if I wanted to organize this with the zeros, it would be positive 1, positive 5, and negative 3. So we have the factoring and the zeros. Number 34. Identify the zeros, their multiplicities, and describe the effect. Now this is already factored, so I can just go right to the chart. X cubed, it's 0. The multiplicity is odd, or 3, which means it's going to cross. The next one, I'm going to add 3 and divide by 2. It has an even exponent, so it's going to touch. The last one is negative 7. It has an odd exponent, so it's going to cross. That's it, to be able to see it. Now, if you didn't, remember the question we did before, you had to do work to factor it and then be able to see it. All right, turn the page. All right, 2 left. If I give you the zeros, can you write the polynomial function? So 0 gives me the factor x, a monomial. X minus 1 would be actually x plus 1. Multiplicity of 2 means it has an exponent of 2. And 4/3, work backwards, so it's actually going to be 3x subtract 4. Now, I'm going to take the first one times the last one. So that gives me 3x squared minus 4x. And then x plus 1 squared gives me x squared plus 2x plus 1 when I multiply or FOIL that out. Simple. It's a simple FOIL. Now, for this one, I might actually draw a little box to organize what's left and then write down the answer. So I have 3x squared minus 4x and x squared plus 2x plus 1. So multiply it out, 3x to the 4th, 6x cubed, 3x squared, negative 4x cubed, negative 8x squared, negative 4x. So I'm going to combine like terms. So I have 3x to the fourth. Negative 4 plus 6 is plus 2x cubed. Negative 8 and 3 is negative 5x squared. And then we have a minus 4x at the end. All right, last one. Can we write these as factors? So if a 0 is positive and negative 5, one's plus 5, one's minus 5. If it's positive and negative 3 root 2, one's plus 3 root 2, the other is minus 3 root 2. So those are the factors from the zeros. Then we're going to multiply the first two together, and you get x squared minus 25. The next two, you get x squared minus. Now, how do I multiply these two radicals together? So 3 times 3 is 9, and root 2 times root 2 is 2. So it's really 9 times 2. So that's where the 18 comes from. And then this is pretty simple to FOIL out. So x squared times x squared is x to the fourth. Negative 25 and negative 18 make negative 43, and it's x squared. And a negative times a negative is positive, and 45 times 18 is 450. All right, so there's a study guide for our unit on polynomials and rationals. Mr. G Math, over and out.